Welcome back to another video of algebraic expressions. So in the previous video, what we discussed was that how to solve polynomials using distributive property and then later on combining the like terms. Now today we are going to do an extremely important topic of deriving couple of very special binomial products. In fact, we'll be deriving couple of very important formulas. Those formulas will help you all through your not just quadratic equations part, but in solving trigonometric equations. In fact, I'll also give you an example that how you can use those formulas in deriving squares of some easier squares like 101, 102, etc. Then of course, since it's a very very important part of algebra, and algebra will help you in your physics as well. So let's consider two binomials for this purpose. Say A first binomial is A plus B and second polynomial is A minus B. Now in first case, what we are doing is we are trying to derive the square of A plus B, that is A plus B into A plus B. Now what we discussed was this entire term will first get multiplied by A, and this entire term, the entire term in bracket will get multiplied by B. So how do we write it? A into A plus B. This A gets multiplied by this entire term gets multiplied first with A plus, now this entire term gets multiplied by B. Let's use the same way of writing, first B into A plus B. Now this is what we studied in the distributive property. Now when we solve this bracket, it becomes A times A plus A times B. Again we are applying distributive property here. A gets multiplied by A gets multiplied by A, later on A gets multiplied by B, plus first B gets multiplied by A, B times A plus this gets multiplied by B, B times B. Now this is equal to, what is A times A? A square. Now let's look for the like terms. A into B and B into A. Are they different or the same? It's like 2 into 3. It's going to become 6. 6 into 3. 6 into 2. It will, 3 into 2. It will still be 6. So whether it is 2 into 3 or 3 into 2, the result will be same. So the commutative property in multiplication. So it becomes A times B plus A times B, and this becomes B square. So let's write in the order of their degrees. So it becomes A square plus B square plus 2AB. So the identity which we have now is A plus B whole square. This A plus B into A plus B, it becomes A plus B whole square. How do we read it? We read like A plus B whole square is equal to A square plus B square plus 2AB. It is like square of first term plus square of second term plus twice the product of both terms. Now we'll take a couple of examples. Let's say, you have a binomial, say 3x plus 9 whole square. Straight away in one line we can write 3 square, it is 9. X square, it is x square. Okay? Plus square of the second term. What is second term? 9. So square of 9 is correct, 81. Plus, now it is twice the product of both the terms. Now what is the product of both the terms? First term is 3x, second term is 9. 9 3 is 27. It is 27x. And what is going to be twice 27x? It is twice of 27 into x, which is 54x. So, no calculations. Straight away we come and write the answer. Now I'll tell you a couple of interesting use cases where you can use this. For example, you have to say calculate the square of 101. How do you do it? You can write 101 as 100 plus 1 whole square. And this is what? A plus B whole square. It is square of 100. So 1, 00, 2 times 0. Plus square of 1, 1. Plus 1 into 100, 100 plus into 2, 200. So what do you do it? Write 1 here, then 0 here, then 2 here, then 0 here, and then you write 1. So you get the answer. Let's take a simpler one. Say you have to calculate the square of let's say 33. You can do what? You can write it 30 plus 3 whole square, and this will be 3 3s are 9, and then we put 00 plus 3 3s are 9 plus 3 3s are 9, 90 and 180. So it becomes 9, 8, and then 10. 33 square is, 33 square is 1089. So this is how you can use it. Even you're calculating your tables. Now we will take the combination of the initial polynomials which we took. What polynomials which we took was a plus b and a minus b, right? So initially we have just solved the square of this. Now we are going to do the square of this, the a minus b. We are going to do the square of a minus b. Let's try it out. A minus b whole square. Now there are two ways of doing it. One way is that we straightway write a minus b into a minus b and then apply the distributive property. So we'll first use this, and then we will use the previous formula of a plus b whole square also, that how we can derive the same identity from that a plus b whole square as well. So let's do it. Okay, so again applying the distributive property. How do you do it? This entire a minus b gets multiplied first by this, and then this gets entire multiplied by this. Let's create some space here. It's better. Yeah. It is a, this a into a minus b. Now it is minus sign. So when we solve it first term into first term, the entire whole in parenthesis into first term plus the entire whole into in parenthesis multiplied with the second term. So this plus and this minus becomes minus. How? I'll tell you. So let's do one more step. It is plus. Now we are retaining the sign of minus with b into a minus b. Now we'll do one more. We'll write one more step, one additional step, just so that you have lot more clarity. A into a minus b. Now this plus and minus will become minus and will become b into a minus b. Yeah, so again applying distributive property, when we multiply a with a and then a with b. So it is a times a minus a times, a times b minus this minus b, and this is plus a. So it becomes minus. It becomes minus b times a. Now this is minus and this is minus. So it will become plus b. Okay. So it is plus b times b. So this is a times a is a square minus ab minus ba. It's one same thing, so they'll add up. So it becomes minus 2ab. B into b becomes b square. So which is equal to a square plus b square minus 2ab. So in the earlier equation it was, when we wrote a plus b whole square, it was a square plus b square plus 2ab, and when we change the sign, only the sign here is changed. So in words, how can we write? We'll write it as square of first term plus square of second term minus twice the product of both terms. Now what we'll do is that we will try to derive the same formula using our a plus b whole square. So what identities which we just derived was a plus b whole square is equal to a square plus b square plus 2ab. In fact, this is the only formula you have to remember, because second formula you can derive straight away from here without applying the distributive property. How? Let's see. That is, what we do is that to write a minus b, we write it like a plus minus b. Got it? What we have done is this plus and minus will become minus, right? So a minus b we are just writing as a plus minus b. Now we put square on both the sides. Now what is the identity? The square of first term. What is square of first term? It is a square. Then it is the square of second term. What is square of second term? Second term is minus b. So minus minus plus. So let's read it. Minus b into minus b. Minus b into minus b. This minus and this minus will cancel out, or they will together when multiplied will become plus. So it becomes plus b square or b square, right? So here it becomes b square, right? So square of first term, square of second term, and then plus twice the product of both terms, twice the product of a and minus b. It is 2 times a times minus b. So this is a square plus b square minus 2ab, and this is that was the formula which we derived. Now again you can use it in solving many squares. Now let's take the example of, say, solving square of 99. Now how we can write 99 as 100 minus 100 minus 1 whole square. Now what's the formula? It is square of first term, it was 10,000, square of second term, and second term is 1 or minus 1, whatever. So it becomes, either it becomes only 1. Then minus of twice of product of these two terms, which becomes minus 200. So this becomes 10,000 minus 200 is 9,800. 9,800 plus 1, which equals to 9,801. So this way you can use these identities or these formulas to solve many things. Now we will do one more important product, which is if we multiply the two polynomials which we have taken. This is the third scenario, wherein a plus b are polynomials which we took, and we multiply these two polynomials. So in first example we did was square of this, that is multiplying this polynomial with the same polynomial, that is a plus b into a plus b. Then we did a minus b into a minus b, or a minus b whole square. Now what we are doing is we are multiplying these two polynomials. So again, what do we do is that we multiply this entire stuff with a, and then later on whatever we have in these brackets with the second term b. So the same distributive property, right? What do we do is that a into a plus b, this first term gets multiplied by whatever whole we have in bracket, and then the second term getting multiplied with whatever value as a whole we have in this bracket. So this is minus of b, it becomes minus of b into the entire term in value in bracket. So reapplying the distributive property on this, we get a times a, which is a square, then a times b. Now this is minus of b times a plus, it is minus, in fact we could have actually, so let's write it this way. Okay, no, cool. It is minus of b square. Now what happens is, this is ab plus, and this is BA minus, or we can say AB minus. So this will cancel out with this, and we'll be left with A square minus B square. So again, this we are going to use extensively in solving our quadratic equations, trigonometry, physics numericals. A lot of places we are going to use it. So this brings us to the end of the three very important products of special polynomials. So I'll just rewrite the formulas. A plus B whole square is equal to A square plus B square plus 2AB. Then we have got A minus B whole square, which is equal to A square plus B square minus of 2AB. And then we have got A plus B into A minus B, which is equal to A square minus B square. So with this, we end this video here, and we'll start the next topic of we'll start the next topic in which we are going to learn about factorization of polynomials, and then we'll move to quadratic equations. Till then, thank you.